It's recording. Okay. Okay. So we're going to continue with radicals today, which is what we start in 7.3. So it is 7.4 if this is going to write. Okay. It is called radical expressions. I got darker as I wrote. That doesn't make any sense, but sure. Okay. Okay, so let's talk about what a radical expression is. Define it first. Sounds like a good idea. Obviously, it contains radicals. And so period. The expression under the radical sign is called the radicand. That's exactly how it sounds. They have three conditions they must follow under the radicand, or whatever the radicand is. Okay, so in simplest form, you can have no perfect squares other than one. Because we're going to simplify it. No fractions. And the last part, move up a little bit, no radicals in the denominator. Which we already knew that. We can never have radicals in the denominator of a fraction. Okay, I know you can't read all that. So those are important things. It's because we're going to simplify them. Okay, so the first kind of property we're going to talk about is called the product property of square roots. I'm going to raise this up. Okay. Okay, so what this means is if we have the square root of AB, so it's a bigger number or two things multiplied together, we can rewrite that, so equals, as the square root of A times, separately, the square root of B. So we can break a big number down into two separate ones, as long as A and B are greater than or equal to 0. So they can never be negative, basically. So I already kind of showed you this the other day, but we're going to really get into it now. So let's start with a real easy basic example. So if we have the square root of 80, and we know it's a square root, even though it doesn't have a number, right? Because that's the lowest root we can have. So there could be a 2 there, but most of the time there is no number there, but it still means square root. So we're trying to say, you either ask yourself, what squared number makes this? Or can you break it down into a factor tree? It's literally up to you. So you can do it one of two ways. You can say what times what makes this, and you want to think of a squared number, which is completely fine. So like 2, that can divide that, but that's not a squared number. So the smallest squared you know is 4. So you ask yourself, if I use my calculator, can 4 divide 80? Yes, it can. When 4 divides 80, what's left over? 20. Okay. My computer's gone broke. Okay, so that's not enough for us, right? 20 is still a big number. So let's divide it by something else. What's the next biggest squared after 4? Something squared makes that after that. 8's not a square. 9 is a square. Is 9 going to divide 80? What's the next biggest square after that? If 4 worked, I would think about what's 4 squared? 16. Does 16 divide 80? Yes, it does. What does 16 multiply by to make 80? 5. So we could rewrite this one, two ways. You can make it as a tree, or you could rewrite it as a square root of 16 times the square root of 5. It does not matter which way you do it. Okay, it does not matter, either or. This one is nice if you use squares every time. Because then we go, okay, do we know ourselves, as intelligent women that we are, do we know what the square root of 16 is? You're going to say it for the peanut gallery to hear you? 4. Is that a whole number? Yes, whole number 4. 5. Can that number be broken down at all? No. How do we know that number cannot be broken down at all? What kind of number is the number 5? It is a prime number. Good job, Lauren. Exactly. You want to break this down to a prime number or something that's not made from squares. So since that's a prime number, you would leave it as a square root of 5, which means we just went from seeing the square root of 80 all the way to 4 square root of 5. And if you type them both in your calculator, square root of 80, find the answer, 4 times square root of 5, they make the same decimal. So they are equivalent. It's just the way they're written. This is just simplest form. So we're going to try this first. Does that make sense? Okay, so let's try another one. So this would really help if we know all our squares, right? So let's think about our squares for a second. Why not? So smallest square we know is 4. What's next? What's the next one we tried? 9. After that? 16. After that? 25. That's 5 squared. After that? 36. Next? 49. 64. That's 8 times 8. Yep. 81. That's 9 times 9. 100. That's the easiest one. Oh, yeah. What's after that? What's 11 squared? 121. Do we know what 12 squared is? 144. 13? No? 169. Think 3 on the 13. 3 makes 6 and 9. 169. And the last, I always go up to 15. 14 is the reverse of 13. It's 196, which is kind of cool. And then 15, 225. Think 5 makes 25, so 15 makes 225. Okay? Knowing those helps because the bigger this number is, right, you want to start with big numbers, right? Because if this is a 4-digit number, would we want to start at the single digit number of 4 to try our squares? No, we want to start at big ones, wouldn't we? Okay. Let's try another example. I might have to get a new marker. Let's try the square root of 180. We want to divide it by the biggest squared we can possibly find. So divide it by the thing that is squared, that number. So it's 30, so trying 49, not trying 7. See what you come up with. Remember, when you get a prime number as its other answer, that's how you know you're doing good. Or a number less than 10 usually, unless it's 9 or 4. How big of a number did you try to start with? Lexi, what's the first number you started with? 25? Okay. That's actually not as big as the number that goes into it. That was a good number in my opinion. Real question is, did you go up or down after that? Did you try a bigger number after that or a smaller number? Okay. Hmm. I'm gonna have to get a new marker. I think the purple worked the other day. We find it yet, ladies? It's only a double-digit number. Most of the time, it's a digit. If it's a triple-digit number, it's less than. It's one digit less than that. Only exception is double digits. Mean 36? That 30 times 6 does not make 180, does it? Oh, it does. But 30 and 6, neither of those are prime. You're not trying to figure out what times what makes 180. You're trying to figure out what prime number divides 180. The answer, huh? But neither of those are prime. Neither of those are squared numbers. So what you could do is on your paper at the top, have these numbers written down. And just go to 100 if it makes you happy. And just go, okay, if the number is greater than 100, try something in the middle. 49. And then try one lesson before, greater than less than. When in doubt, you can always start at the beginning or the end. But it is 36 and 5. 36 times 5 does make 180. And then the square root of 36 is the number 6. And we know 5 is a prime number. So the answer is 6 square root 5. But this is what I do, but I just do it in my head. But it might help to have this list on your sheet, on your homework sheet. When you take the test, have that list of primes out for you and think, okay, which one of these will work? Okay. Let's try one more. Good thing I got a third board. Let's try another marker too. How about the square root of 54? So that's a small number. It's never going to be the number closest to it. That's prime. So never try 49. That's a small number. I would just start at 4. Does it divide by 4, which is a squared? If it does, okay, we'll try the one that 4 makes. If it doesn't, just try the next one. Oh, I forgot 9 on my list. Try 9. Try 16. Do we get this one? What times what makes 54? That's a squared. 9 times 6. You always put the squared in front because what's the square root of 9? Whole number 3 You leave the square root left over. 6 is not a prime number, but does anything make that number that is squared? 6. Only thing that makes 6, right, is 2 and 3. Because we can't include the number 1 ever. So that's it, okay? So you're going to use this logic to also go the opposite way. So if I give you square root of 2 times the square root of 14. You have two options. You can say, okay, are either of these squares? Nah, they're not, right? So you can combine them and turn them into 28 and say, let's re-break them up as a number we like. What one of the small, tiny little squares we got actually makes 28? Yep, 4 times 7. Which really that answer is going to be 2 square root 7, because square root of 4 is 2. That's one way you can do that. Okay, that's using your prime. That's using prime numbers and squares, perfect squares. Okay, the other way, which it sometimes is helpful. Some people like this, some people don't. It's just up to you. Okay, it depends on which one you're, I would say, faster at, so you can get your stuff done. Okay, the other way to do this is a prime number. Yes, remember how we did the factor tree? Yes, 2 days ago. So you go 14. Can I break this down into 2 things that make it, not using primes, not using squareds? Can I make it into 2 prime numbers? Because I break it down as small as I possibly can. This is the other way to break down square roots. Can I take the number 14 and say what times what makes 14? 7 times 2, right? And this already has a 2. So this really means I have the square root of 2, the square root of 2, and the square root of 7. What do you notice here? I have 2 of the same thing. Do you remember before when we did it the same way, where we did it this way? And we circled when we had 2 of the same thing, we could pull it out. When you have 2 of the square roots also this way, when you have 2 of the same square root, that turns into the whole number 2. Because the square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. So it just honestly is a personal preference kind of thing. So if you like the perfect squares and you're good at perfect squares, use it. If you like the factor tree method, this is my favorite method, but I'm fast at it. Okay, so it is a preference thing. Okay, I'm going to give you a number one and I'll let you decide, because we have to throw variables in here at some point, but we have to be good at that before we move on. Okay, how about square root of 5 times the square root of 10? Pick a method. I'm going to do the factor tree method. I'm going to turn it into one number and do the factor tree. It's up to you. You could have also had this. Same answer. No matter which way you do it, you get the same answer. It's the best part about math. Which way do we like to do it? That'll help me understand how we're going to learn variables. Which way do you like to do it, Ava? Lauren, you agree? Cam? You like the squares? Okay. Kimberly? Okay. Christina? Lexi? Okay. Okie dokie. We'll see. See how you feel. Okie dokie. And then I get to just show you both ways. It's a fun time for everybody. Okay, next, same thing. We're just going to have variables. Okay, square root of, ooh, this is real ugly. Okay, 90, then x to the third, y to the fourth, z to the fifth. Okay, now you do one thing at a time. You do the number first in your choice of method, whether you're going to do the factor tree way or you're going to break it down with your perfect squares, okay? So everybody just break down the numbers. Just put it straight underneath the 90 and find the answer. Try it out. I have my answer. I'm just covering it up. Do we all have number answer? Do we all have the same number answer? Okay. Now, these can be done both two ways, so I will show you both of them, okay? Now, I'm going to just scoot this just a little bit this way for me. One way is, what number again is right here? 2. Okay. So what you do is, you have to look at every single variable individually. So look at just the x's first. Is that x even or odd? It is odd. I actually need to move this. Okay. If the x is odd, that means we are always going to have, if something's odd, you're always going to have something left over underneath the radical. So I took an x out. If I took this x out, how many is left? 2 of them. Okay, so I'm just going to, if I was writing this in pencil, I would write x squared underneath. Okay. So then you go, you take what you do that with every single one. If you didn't divide it, I just rewrite what I have. So the y to the fourth, I just keep it because it's even. Z, it's odd, so I'm going to hold on to a z. I'm going to have z to the fourth left over. Then from there, whatever this number is here, right now it's 2, but yours is it's going to change later, okay? You take this number and you divide their exponents. Whatever that division is, it goes on the outside. So 2 divided by 2 is 1x. So x to the first power. y to the fourth divided by 2 is y to the second power. And z to the fourth divided by 2 is z to the second power. So your final answer is 3x y to the second z to the second square root of 10xz. All that stuff is underneath the radical. So with exponents, you're dividing them. The whole numbers you're using, you're also dividing the whole numbers, aren't you? You're saying what divides that number. So the operation stays the same. Okay? The other way to do this, for those of you who like the factor tree method, okay? The only problem is sometimes it gets a little bit too much, is x to the third. The other way to do this is going, hey, I have 3 x's. How many groups of 2 can you make? I pulled out one group of 2. That's why I only have 1 x. Whatever is left over stays underneath. It's the same exact thing. Y to the fourth, you had 4 y's. I had a group of 2, a group of 2, because that told me 2 y's, so I'm going to write y to the second. Same thing with z's. Z to the fifth, 5 z's, a group, 2 groups of z's. I had 1 left over. They are the same thing. The only thing is that this one is actually really beneficial, right? Because sometimes this number gets crazy, and also sometimes it's exhausting to write this out, right? So it is a personal choice. Okay, we'll do some more. Don't you worry, we're going to practice. Okay. Already had this open. How about, oh, I forgot one thing. I knew I forgot something. The last thing about that, if little star, put a little star, and this is a note. Okay. I'm trying to say how to say it. If your radicand variable starts out even and how do I describe this? And is simplified with an odd degree. You must use the absolute value sign. I'll show you what this means. I knew I forgot something because I hate it. I'll show you just a little tidbit. So if we have the square root of x squared, so like the one we just did, when we divided, this started out even, but when we divided it, our final answer, right, our simplified answer, it was odd, wasn't it? That thing, only the x, will end up with absolute value written around it. Just the x, because that's the only thing that started even and ended odd. So if we had like the square root of x to the third, right? Since this starts even, since this starts odd, however we simplify this, it just stays exactly how it is. So since it's odd, there will be 1 left underneath, and there will still just be 1 left over because when we take 1 out, 2 divided by 2 is still 1. But since it started odd and ended odd, we're fine. But if it starts even and is divided to be and then divided to be odd, you have to put the absolute value on it. So the problem we just had, right? This guy right here, this x, because he started odd and ended odd, we're okay. He's fine. But the next problem we're about to have is going to have some evens that turn odd. That's like this is like one of those weird rules that you forget because it only happens here and never anywhere else. But we will remember, we will get through it. And you will get reminded. Okay. Okay, let's try a couple. Let's do the square root of 32 r squared k to the 4th t to the 5th. So try your own method. Write down the numbers, try the variables, don't forget that absolute value at the end. Cameron, you already finished? I'm going to unfreeze mine so you can look at it when you're done. How are we doing? Did we get the same answer? Does it make sense? Are we wanting to change our mind on how the process we do this? No? You okay over there, Eva? Okay. What I do, I like the factor tree method, but what I do with factor trees is sometimes the numbers you literally just don't know anything that goes into them, which is when it's really helpful. With the variables, I weirdly do my numbers the factor tree method and then my variables this way. I mix and match because the variables, it takes too long to write them all out. But the numbers, sometimes, like when the numbers are so big, you just don't know. So sometimes it's just easier to divide by 2 or by 3. But this one, I knew 16. And so since I know 16 is a square, that I just could just change it right away from me. Right? And it'll take practice. Again, Christine gets mad at me, right, when I go too fast. That's why you don't let me up at the board anymore. So it just takes practice, which is a good thing is we still have this whole section, and I think all the rest of it has radicals in it too, so it'll be okay. We will get the practice. Okay? Everything we have to do is have radicals in it. Okay. Bless you. The next one is called the quotient. Oh, it's already starting to die. Property of square roots. So the quotient property of square roots. How does this happen to me? That one looks nice. We'll see. So all this means we're going to have a fraction. So if we have, oh, man, I can't win today with the markers. I really can't. So if we have a fraction, oh boy, a over b, and it's all under the square root together. All this means is we are going to separate them. So we're going to break it down to the square root of a over the square root of b. So we're just going to break the numerator and the denominator up so we can focus on them and look at one at a time to see if we can simplify it. Okay? Because we never want a radical in the denominator. It's against the law. We don't like it. Okay, so if we do it, we have to fix it. So this is where our calculators and our math knowledge helps us. A lot of times, this is where you get crazy multiple choice questions. So if you have the square root of 35 over 15 as your problem, first thing you're always going to do, I always look at it and go, okay, let's just break this into 2 separate ones. And then you pray and hope for a second and go, are either of those numbers perfect squares? Sadly, no. If they were, it would make our lives easier because we're not allowed to have a square root down here, are we? Ever. So to get rid of the square root down here, do you know what you do to get rid of the square root in the denominator? That's a nice thought process, but no. It's not that easy. Because it's in a fraction, to get rid of anything in the denominator, you either do its opposite or you apply it to change it. So with square roots, you apply it to change it. So you're going to multiply, and I'm going to throw this marker out the window, times the top and the bottom by whatever the denominator is. Ooh. Okay? The reason you do that is because this square root of 15 times the square root of 15, right? 15 times 15 makes 225. And what happens when I take that square root? So you're going to multiply them, 225. And I already told you that the square root of 225 is what? Whole number. Remember? I'll give you a hint. It's 15. So when you multiply, so you never have to do this again. When you multiply by the denominator, the answer always is the whole number under the radical. It's that radicand. So when you multiply by the denominator, you're getting rid of that radical sign, basically. Then on the top, those two numbers, can we make them one number? Let's make that one number. 35 times 15. What's that ugly number? Oh, well, that's way too big. And I'm looking at all my multiple choice answers, and none of them are that easy. So maybe we should try simplifying it. So, but can we simplify the square root of 525? I would hope so. It's got a 5 at the end. You can't simplify it at all? Yes, you can. They both have to be divisible, but they have to be divisible by a square. $20 says that's divisible by 25. 3. You did 15 divided by what? Huh? Well, don't divide by 7. You just went too far. Here's the thing. What makes 35? This is how I knew that answer. What makes 35? Think of the number 5. 5 times what? What makes 15? 3 times 5. Do I have 2 of the same number? Since I have a perfect square makes that. That's how I do it in my mind. So we can rewrite this as a perfect square times something. So this is 25 times what, 21? So we can rewrite square root of 25 as 5 square root 21, because that can't be broken down, sadly, all over 15. You want to try another one? Just like that, different numbers, but still ugly. Ugly things, they're great. You almost always can simplify something. Almost always. Okay. How about easier numbers, but throw something at you? How about the square root of 6y over 12? Can we break this up? Square root of 6y over the square root of 12. Now, how do you get rid of the square root of 12 in the denominator? Yup. I don't actually have to do the math. What does the denominator turn into when I do that? 12. The top, can I actually multiply those two numbers together? Are they numbers? Yes, then I can multiply them. It doesn't matter that it has a y, because we're multiplying, not adding. Or I can look at my cheat sheet and go, I know that this is 6 and 1. I know that this is 6 times 2. So, think about it. If not, do the multiplication. Simplify the radical. I know the answer already. What's the simplified top? I'll give you a hint. Y is underneath the radical. Don't be confused by this. What is the simplified answer after you multiply and reduce that radical on the top? 9? 81 divides that number? Remember, what is 6 times 12? 72. So underneath that radical, before we try to break it down, is 72y. So break down the number 72. What squared divides 72? Which squared number divides 72? No. 9 times 8 does, yes, but 8 is too big of a number, so 9 will not work. Because 8 has a square in it, it's not a small enough number. If 8, yes, 36 times 2. So then what's the square root of 36? So 6 is on the outside. What goes underneath the radical with the y? A 2. This fraction right here, look at the whole numbers. Can that be simplified? 6 over 12? Yeah, Lauren, what's it simplified to? 1/2. So 1, I don't really need to write the 1, right? 2 on the bottom. I still have the radical of 2y. I can put the 1 there if I want. But it does not mean anything. Is this a lot? Let me see. See what we got going on in here. What about, I'm going to do this for you. I'm going to change your homework. So wherever you wrote your homework down, let's change it. This is for everybody. I'll have to change it online too. Okay, let's change your homework to be the same page, so page 425. I would like you to do 3, 6, 9, I'm just counting. I would like you to do 32 through 44. That's it. 32 through 44. I'm going to write that down. My marker would work. Okay. That covers simplifying square roots, combining the square roots, some variables, and some fractions. Do that. Come back, and then we will cover the other part tomorrow. Okie dokie. Okay.